Today we're at the Cambridge Museum of Zoology and we're in their micro-CT scanning department. We're going to be talking quite loudly over the noise of the machinery behind us. So Dean?
Yes, I'm very happy to introduce Dr Laura Porro. We've brought along the Ichthyosaur bones today and we want to learn a little bit about what the CT scanner is and what we're going to do with these bones.
Alright, well, a CT scanner essentially stands for computed tomography, and it produces a 3D X-ray of the specimens. So CT scanners are used quite a lot in medical fields. The micro-CT scanner is basically a high-energy version of medical CT scanner, which allows us higher resolution for smaller specimens and also greater penetration for very dense specimens, including fossils. And so what we're going to be doing is scanning individual pieces of the Ichthyosaur skull. First step is mounting them in order to place in the scanner, and we're using this fluoroscope, which is very low density foam that will basically look like air to the CT scanner. And we're placing the individual pieces up on their long axes so that we get maximum penetration of the X-rays from the CT scanner through the specimens.
Yeah, sounds very exciting.
So as I said, the first step is mounting the specimens, and we're using fluoroscope, which is really easy to carve. Gets everywhere though. It looks like fairly crude work, but we'll make it look nicer as we go along. There we go. It's very dynamic. Just basically carving it out to match the shape of the specimen. We can refine it more as we go along. So the idea is that at the end, the specimen will be able to sit in there, and it won't move, most importantly, during scanning. So the CT scanner will slowly rotate the specimen as it scans. And so it's important that it not move, because even the slightest shift in the position of the specimen will blur the scanning and reduce the quality of the CT scans.
Laura, could you explain exactly what you're doing there, what's happening?
So what we're doing now is, it's important to make sure that as the platform that's holding the specimen is rotating, that the entire specimen is fitting within the shot. We don't want to lose any part of the data. And at the same time, we want it to be as close to the X-ray source as possible so that we get maximum resolution.
So you get as much detail as possible.
Correct, without losing anything in the specimen. It's this very fine balancing act.
Yeah. Excellent. So having these Ichthyosaur bones micro CT scanned, we're able to have them on computer screens, manipulate the data, turn around these bones and see them in 3 dimensions. So what else does that add to our sort of study? What else can we look at on these bones?
Well, in addition to what you said, which is that you can manipulate the elements in 3D and not worry about the damage of the real specimen anymore, or in the case of heavy specimens, dealing with a heavy specimen. You could also look at internal details, so things like vasculature that may be going through the bone, as well as the nature of sutural contacts between the bones of the skull, which could be quite important for the mechanics of the animal.
Sure, that's really exciting stuff. Let's see what we can find out with this one.
Absolutely.
We're just looking at some of the CT scans which have been produced there of some of the bones, and this one on the computer screen is a tooth. Laura, how cool is this?
It's really good. Very nice high-resolution scan, so you can see this the sort of rounder fluting grading into the very fine fluting. And you can actually see a pulp cavity within the tooth here in the scan. So some good data today, I think.
Yeah.
Dr. Dean. Oh, that might be a little bit of our enamel dentine boundary right there. So
cool.
Good time.
Yeah, good stuff.
So this is the interior of the brain case. We're looking at essentially a natural mould in the roof of the skull of the shape of the brain of this Ichthyosaur.
Which would have been in this depression in here, these double depressions. If I zoom out slightly, and rotate, you can see this space in here, and these two.
We finished scanning all the bones and the tooth, and we had quite high hopes for today. We brought, I think, 10 different specimens. Some of them were really dense, some of them were really complex. Then we had a single tooth, and I think they've all acted quite differently in the scan, haven't they? How do you think things went today?
I think things went pretty well. We got excellent surface scans of all the specimens. There were a few specimens, such as the humors, that were much higher density than we were expecting, which is interesting in and of itself.
So that might have pyrite or something like that.
Might have some sort of iron deposits within the bone. We found that one of the bones had a bit that was a fake.
That's right, there was some gap filler that was very well crafted, and so the bone was slightly different shape to what we thought it was.
But it couldn't fool the CT scanner.
No, that's something that was revealed through CT scanning. And what do we have here? And why is it this colour?
And we have the parietal here, so it's one of the bones of the skull roof, and it's this color because we've made it this color. We can make it whichever color we want. And sometimes doing that helps because making it a constant color, you actually aren't distracted by differences in color, and you can really see the morphology of the skull. So you can make it red if
Because
you
when
want.
you're looking at a fossil, there's all sorts of shades of brown in there and grey and other things, and your eye can be misled by that quality. If you just see a single colour, you're actually seeing things in a lot more detail than you would do otherwise. Strange though it looks.
Alright, so now that we've got these, the next steps will be to try and reassemble the skull from all the individual pieces. Of course, we have bones mainly from the left side of the skull, so what we'll do is we'll duplicate the elements we have, mirror them across the midline, and make the right side as well. And then we'll have a more or less complete brain case.
That's pretty cool. So then we're going to have all these sort of elements put together, sort of, to show a complete brain case, and then potentially even have them sort of 3D printed. And we can build up the opposite side of the skull, right?
Absolutely.
Yeah. Thought it would be quite nice to have that. We can then replace all of the wood.